Okay, listen very carefully, please. Much of what is difficult can be very much figured out by thinking about what is simple. And another way of saying adding and subtracting rational expressions is no more than adding or subtracting fractions. So now before we go into adding complex fractions together, let's think about adding what you've done since 5th grade in the world of simple fractions. Let's just look at the process of this. If I take 7/8 and add 1/2 to it, think about the procedures that you have to do. In other words, in order to add fractions together, what has to happen, Eli? You have to make what we call common denominators. Make common denominators. If they don't have common denominators, you can't add them together. Now, then you have to think about, well, what do I have to do to get common denominators? Another name for a common denominator is what? If you have 2 and 8, to find out what your common denominator is, what is that called? I'll give you a clue. It's not the greatest common factor, but it is the least common multiple of the two. What is the smallest multiple that both of these have by least common multiple? And that, in this case, it's easy because it's 8. Okay, and then when you do that, what do you have to do? You have to, say what times 2 gives me 8? 4, and then I have to do the same thing to the top. And what times this gives me 8? 1, and I do the same to the top. And then your last step is you keep the same bottom, which is 8, and you add the tops together, which is 11, and then of course, always simplify. If you just keep that in mind for what we're doing today, it'll be a lot easier than what you think maybe it'll be. For example, starting off easy here, from the book, here's one problem. 2x squared over 20x plus 3x squared over 20x. And I guess I forgot step number 1/2. You still need to write these up and down. When you get out of my world, you can do it however you want, but in my world, you need to do that. So it's the same thing, 2x squared over 20x plus 3x squared over 20x. What do I get when I add those together? Luckily for you right now, they have common denominators. So what's my bottom going to be? 20x. What's my top going to be? 2x squared plus 3x squared is? 2x squared plus 3x squared is 5x squared. And then I just need to simplify. What can I do there, Jacob? Yeah, 5 goes into 24 times. X goes into x squared 1 time. So I end up with x over 4, or 1x over 4. That would be the answer. That's a simple one. We shall go harder. One step harder. How about this one? 3a minus 2 over a plus 2 minus a minus 6 over a plus 2. Same first step is right up and down. Common denominator is a plus 2. It's already done for you, so you don't have to worry about the bottoms. Now here, children, for those of you already starting to zone out, please zone back in just for a second here. Okay, take a look here. When you see a subtraction problem, you have to do a little thinking here. This subtraction sign, you have to think about this as being in a parenthesis for right now. And when you subtract it, that subtraction sign gets distributed out to both of those things. So in other words, that really makes this a minus a, and it makes it a plus 6. So when you put these together, you have to think about their opposites, because that's what a subtraction sign does. So when you put those together, your a plus 2 stays on the bottom, and you don't have to change that. Okay, you're going to take a 3a minus an a, which gives you 2a. You're going to take a minus 2, put it with a positive 6, which gives you plus 4. Now, am I done? Does anything cross off? Can I cross off the a's? I cannot. Not unless it's multiplication. You can only cross off factors, and these aren't factors. The only way the bottom will cross off is if by somehow you end up with an a plus 2 in a parenthesis on top. Michael, can I get an a plus 2 in a parenthesis on top? I sure can, because what can I take out of both of these? Remember that whole you got to factor out if you can? If you take a 2 out of both of those, you're left with 2 times an a plus 2. Then, children, since these are both in parentheses and factors, this one's a factor of 1 if you like, this will cross off, this will cross off, and you're left with just the 2 on top. This is kind of a combination of a lot of the stuff that we've done. It's just you have to put it all in practice. Evan?
Why is 3a minus 2 2?
Why is 3a minus a 2a? Because I have 3 a's. A plus a plus a, and if I take one of those a's away, I'm only left with 2 a's. It's not multiplication, it's not a cubed or a squared, it's for adding. You ready? Because here comes the big deep breath. A little more complicated. Let me find one where it's complicated. Okay, ready? 2h to the 4th over 6h plus 4h squared over 2h squared. Ready? Because here's where we have to start thinking here. Besides the fact that you could actually simplify both those, we're not going to go there, but we're going to do it there. I'm going to write it up and down first. 2h for 6h plus 4h squared 2h squared. These, first time we've come across ones that don't have common denominators. So you are going to have to figure out what the least common multiple of these are. What is the smallest, and you don't have to use smallest, but it'll save you time in the end. What's the smallest thing that 6h and 2h squared will go into? And you have to think about least common multiples there. Well, let's do the number first. If you had 6 and 2 as the bottom of your fraction, what would be the common denominator of 6 and 2? 6. So you know that's the numerical part of it. If you have h and h squared, what's the smallest thing that they will go into, not that goes into them? Huh? Is it h or is it h squared? It has to be h squared, people, because if it was just an h, what would you multiply h squared by to get an h? You can't do it. You'd have to divide. So it has to be, remember with least common multiple, it's what you take the group that has the most, not the one that has the least. Which one has the most h's? So now here's where you go back to what we did when we did other fractions. Now you have to do this. You have to go, okay, to go from 2h squared to 6h squared, I have to multiply by a 3, so I have to multiply the top by a 3 as well. 4h squared times 3 is 12h squared. What do I have to multiply 6h by to get 6h squared? H. So I have to multiply the top by an h, and you get 2h to the 5th. Are you with me? Now they have common denominators. You can keep your 6h squared, and you are adding this plus this, which unfortunately they're not like terms, so you can't put them together. You have to write it out like this. It's 2h to the 5th plus 12h squared. Are you with me? These are not like terms. You can't put them together. You need an h to the fifth to put them with 8. Did I do something wrong? Okay. But you do have to see if you can simplify. And because of this addition sign here, you just can't split this h squared with that h squared. You have to make this multiplication on top. That's why you need to factor on top. What can I take out of both of those? You can take a 2h squared out, a 2 times an h squared. What am I left with? An h cubed, because h2 times that gives you that, plus a 6. I probably should have put those parentheses there because I probably confused you, but it's 2h squared. I took a 2h squared out of that, and I was left with an h cubed. I took a 2h squared out of that, and I'm left with just a 6. Now, these are all factors. This times this times this. You can cross off if you see something there. An h squared will cross off with this h squared, and 2 and 6, 2 goes into 6 3 times. So what's your answer going to be? You're left with an h cubed plus 6 all over 3. And this 3 can't cross off with that 6 because that's not a factor. It's an add-end. That's the most that you can do. Isn't that kind of a wow sort of thing? Now you want the really scary one.
Yes.
No, this one gets better. This is for all of you really deep thinkers. Check out this problem. X plus 3, write this down, because if you get this, you're in a league all of your own. X over x minus 4 minus 2 over x squared plus x minus 20. This is where you need at least a half a sheet of paper to do this. Just follow the same rules. What is my first step? Write it up and down for me, please. X plus 3 over x minus 4 minus 2 over x squared plus x minus 20. And here is where the wheels fall off the old train cart. Oops. What's my common denominator?
I don't.
Jacob?
Alright, is it an X? Alright, no.
What's the smallest thing that both of these will go into? Now, before you answer that, before you figure out your common denominator, you should always look to see if you can factor. Oh, look at that. I know I can't. I don't know any grading codes. Okay, work with me here for a minute. I can't change this. This is in its simplified form. But I could factor this out. Anytime you see a trinomial on your bottom and you're trying to find common denominators, what time? Reverse FOIL gives me what when I multiply this to get this? I get a x and an x. What times what gives you negative 20? Add together gives you positive 1, Eli.
Negative 1 positive.
Now, right now, a light should kind of come on in your head because I have a negative x minus 4 here and an x minus 4 here. What is my common denominator?
X minus 4.
And you still need this too.
X.
Your common denominator is, remember you take the group that has the most of each factor. This group both has one of those, so it is x minus 4, but you also have to take this x plus 5. That is my common denominator that both of my bottoms will go into. What goes on top up here? These are already the same, right? So the top stays the same, which is a negative 2, because nothing changes, it's the same fraction. But this one, ladies and gentlemen, To go from this to this, I need to multiply by what? This whole thing is missing, right? You need to multiply by x plus 5. So I need to multiply this times an x plus 5. Before I answer Calvin's, I actually need to multiply that out. So it's FOIL. If I multiply that out using FOIL, I get x squared plus 8x, yes, plus 15. Then, Calvin, I can actually take this 2 away from that 15 to give me, I get x squared plus 8x, sorry, and I can take 15 minus 2 and get 13 all over x minus 4 times x plus 5. Then, you'd have to try and see if you can simplify that, and it would only simplify if you can factor this into 2 binomials and one of them would match one of these 2. But I don't believe that's going to happen because nothing times nothing gives you 13, except 13 times 1, and there's no way to get 8 with a 13 and a 1. So this really is going to be, now Calvin, your question.
I'm just confused how you can multiply x minus 4 times x plus 5 and then it just equals x plus 5.
You lost me. You're confused why this happened here?
When you get
Well, this x minus 4 times x minus 5 is this x minus 4 times x minus 5. I just left it, I didn't actually multiply it out, I just left it as 2 factors times themselves. Because in the end, I want to factor them anyways. You know, maybe the book would give the answer like this. It might give the answer as x squared plus x minus 20. Over that, I don't know. Either way, it does, it's fine. But you don't have to multiply this because in the end, you're going to factor it in to see if you can simplify it. If you caught 60% of that, you're probably doing not too badly. If you caught 7% of it, then let me see what they actually gave the answer as. Yeah, they just left it like this. This was the answer they had in the book. This children is some pretty deep thinking even for algebra people, mostly. Well, there's a number of steps there.
How do you remember all this?
I do remember this. This is something that, this is not, I mean, it's something you run across a lot in the math. Let's try one more. I don't know which one to try. I could give you one more thing, but I don't want to. I don't want to. Sure, why not? Here. How about this one? One exciting problem here. X over x plus 3 minus 3 over, I thought we were doing something else today. I was a little more excited about it, but this is not. X squared plus 5x plus 6. Want to give it a go? I mean, just know this, children. The reason the book gives you this problem is probably this one's going to factor into how this is one of its factors. I mean, they do try to make it work out a little bit for you. Because if this doesn't have that as a factor, your common denominator is this times this, which would be very ugly. So here we go. Step by step. First thing, write it up and down. I'm left with this, right? X plus 3 minus 3 over x squared plus 5x plus 6. We have to try to find a common denominator. So you want to factor this. What's my binomial? What times what gives me this? Why can't for a horse? Grace says
X plus 6 and x.
it would have to be 6 and 1. Can you get a 5 with 6 and 1? Yes. but they both have to be positive.
Yes.
Like I said, usually they try to give you this as one of them because you want it to be able to x plus 3 times x plus 2. So what is your common denominator? X plus 3 times x plus 2, since that already has it at x plus 3. X plus 3 times x plus 2 and x plus 3 times an x plus 2. What am I missing here? Nothing, so the top stays the same. It's a minus 3. What am I missing here? I need the x plus 2. So what happens when I multiply x times x plus 2? Somebody?
X squared plus.
X squared plus 2x. Ooh, look, maybe this is going to get exciting, kids. When I add the tops together, I'm left with x squared plus 2x minus 3 over x plus 3 times x plus 2. And the only way that is going to simplify is if I get one of these two factors on top. What does this factor into? This one does factor. What times what gives you negative 3 when added together gives you positive 2. Lutz.
X plus 3, x minus 3.
X plus 3 times x minus what?
1.
Correct. Now, here you go. Oh, look at that. This is so neat. They both have x plus 3's. I can cross them off. And my answer is just x minus 1 over x plus 2.
You know.
Who feels pretty good about that? No,